All right, good morning, good morning. We are now on our last topic for trigonometry, which is our polar equation for conic sections. So first of all, what is the form? Polar form for this, so we have the following here now as such. R is equal to, okay, hopefully I can write in here. There we go. R is equal to, what are we using in here? We're using K, okay? So R is equal to KE all over 1 plus or minus E. This one can be either sine or cosine of an angle theta, okay? So that is our polar form for this. And from here, it will depend on our E, what we call eccentricity, whether it is an ellipse, a parabola, or a hyperbola for such. So with that being said, let us now identify that. E is basically our what we call eccentricity. And it's basically the following formula in here. That is PF over PD. This is the distance from any point to the focus. And this one is basically the distance from that same point to its directrix. Our K in here will tell us something about the directrix of our conic section, whether that be parabola, hyperbola, or ellipse. And also the eccentricity will give us an idea on whether it is as follows, okay? So here it is, E. So if our E is less than 1, but still positive, we call it an ellipse. If our E is equal to 1, then that's basically a parabola. However, if our E is greater than 1, then that is our hyperbola. Also, the sine and cosine will tell us if it's going up, down, or left, right for such. So with that being said, if it is sine, then that means it's either going up, opens up or down. And cosine certainly will tell us if it's opening left, if it's negative, or positive. So let us analyze that one now in here for such as this one in here. For example, we said in here, write the polar equation of the conic for each value of E. Identify the type of conic represented by each equation. Verify your answers with a graphing utility. For example, in here, if we have R equals 2E all over 1 plus E cosine theta, with E being 1, then this can be written as such, 2 over 1 plus, our E is 1, cosine theta. So with that being said, our E is equal to 1, or what we call eccentricity, which means, what type of conic section is this one, Elena? What do you think? If our E is equal to 1. Is it an ellipse, a parabola, or a hyperbola? Parabola. There we go, right? So this is actually a parabola. Opening where? Well, as you may notice in here, this is positive cosine. So as you may notice in here, if it's positive cosine, then it should be opening to the right, okay? So while seeing the rest of them first, let us identify how it looks like, all right? 2 all over 1 plus cosine theta for such. So here it is. R is equal to 2 all over 1 plus cosine theta. I'm going to set my A now in here as 1, okay, because it's a parabola. Okay. So if you look in here, oops. Okay, so that's our A cosine theta for such. R is equal to 2 all over 1 plus cosine theta. Our A is equal to 1. As we may know, it's a parabola. Oh, sorry. This one is opening to the left, however. Okay, so that is left for plus. Sorry for that one. So let's check on this one in here for such, right? Left is positive and right is negative. So here it is. Oops. Also, after that, let's identify the directrix for such. So it says in here, whatever our K is, that is the directrix for that. So in short, in here, our K is equal to 2. Oops. K being equal to 2 means the directrix is at where? Directrix at x is equal to positive 2. Okay, so if we look at that one in here, where's that gonna be for such? If I put in here x is equal to 2, that's where the directrix is gonna be. And certainly the focus is at the origin for such, okay? So again, that's the vertex. That is the focus, and that is the directrix for such. So which means that the distance from, so what it means is that eccentricity meaning 1, meaning what? The distance from any point to the vertex and any point, any point, say this one, to the focus, and any point of the directrix are the same, or that's equal to 1 for such. Okay. By the way, in here, what is the polar coordinate of the focus? What's the polar coordinate of the focus in here? Certainly, the focus is at the origin. Okay. The vertex is that means what? R equals 2 and the angle is equal to 0. Okay, so we can see that one as R equals 2 with angle being equal to 0. Okay, that is where the vertex is. And the directrix is at x equals 2 for such. Now, let us identify now the rest of them for that. Let's look in here as follows. Okay. Okay, so trying to identify these in here first. Here it is, okay? So this is the focus, 0, 0. This is the vertex at radius 2, angle equal to 0. And this is the directrix, okay? At x is equal to 2. So the eccentricity is as follows for such, which means that if we connect the focus to any point in here, let's say at this point, okay? So the distance from here to here, that is any point P to the F, okay? And from any point to the directrix, which is shortest distance is the perpendicular, which is the D, that means these two should always be the same for that. Okay, and that is your eccentricity. PF, the distance in here, over PD. And again, A equal to 1, that means E equals 1, that means this is a parabola. And the 2 in here means K equals 2, means that is the directrix. Okay, let's look at the rest of them in here. What now if your E is 0.5? So if our E is 0.5, what's going to be our equation for this one? What do you think? So 2 times 0.5, that's going to be 1 for such, all over 1 plus our E is 0.5 cosine theta. So if our E is less than 1 but still positive, what type of conic section are we looking for? An ellipse. Okay, so let's figure it out, guys, in here. What now if that is like such? Okay, so this is an ellipse, and let's see how it looks like. Okay, 1 plus 1 all over 1 plus 0.5 cosine theta. So if we look at that one in here, so I'm gonna change my A now to 0.5 instead. That's the eccentricity. Okay, so as you may notice in here, like that, I'm gonna remove this directrix first. That is our ellipse for this, okay? Where do you think is the focus of this ellipse? Certainly is at the origin in here still, okay? There we go. So that is our ellipse for that. What now if that is what? 1.5. So if this is 1.5, 2 times E 1.5 is equal to 3. Okay. So that one will now be equal to 3 all over 1 plus our R now is 1.5 cosine theta. So with that being said, if our E is 1, that's parabola. If our E is less than 1, it's ellipse. But if our E is more than 1, then we're looking for a hyperbola for such. So this is a hyperbola. So if we take a look at that and see how it looks like, let's see, guys. Okay. So I'm going to change now this to E equal to 1.5. And as you may notice in here, that is our hyperbola for that. With that being said, okay. So where do you think is the focus of this hyperbola? Still the same, at the origin, okay. So as you may notice in here, this hyperbola, its corresponding parabola and its corresponding ellipse have what in common? What do you think is common between all of those, guys? Anyone? So as you may notice in here, the commonality is that they all have the same focus at the origin, okay? So put in here all focus point at the origin 0, 0. Okay, so there we go. So once again, that is our polar equation for any of the 3 types of ellipses. If E is less than 1 but positive, it's ellipse. If E is equal to 1, that's parabola. And if E is more than 1, it's hyperbola. Now, how do we do now such that this will be the case for that? So once again, so there's one more in here. Certainly, if E is equal to 0, then that means we are looking for a circle instead for that, okay? So, let's verify in here how to analyze this, okay? So here it is, we got the following. Yes.
Is that a new paper?
Oh yes. If here we go. Sorry, Jujo. Jujo, can you distribute this one, please? Thank you to everyone. Thank you. So how to analyze polar form of conic sections? Step 1, okay? Make sure that the denominator constant term is equal to 1. So how do we do this? All right, so here it is. Jojo, can you read this one first? How to analyze polar form of conic sections. Step 1 was our first step.
Make sure that the denominator is a constant. Sorry. The
Denominator constant term.
Constant term is 1. Divide both numerator and denominator by this constant term.
Thank you. Okay, so that's the first thing that we're gonna do. Make sure that the constant term on the denominator is equal to 1. For example, in here, we have what? R is equal to 2 all over 2 plus cosine theta. So you see the denominator constant term, that's 2. So what do you do to make it 1? Well, as we said, divide both up and down by that constant term. So what is that constant term? 2. So that's what we're going to do in here. Divide both up and down by 2. So with that being said, 2 times 1/2 is equal to 1. 2 divided by 2, that's equal to 1. And this will now be 1/2 cosine theta. Okay, so again, we have now changed this given polar form into such. Okay, so always, this is the goal. To make this constant term on the denominator equal to 1. And how do we do that? Well, we both divide up and down by that constant term. Now, after that, what do we do then? Step number 2. Here it is. Step number 2. What do we do? Okay, Jujo, let's read this one in here. Step number 2.
Identify the E value
Eccentricity
to determine if it's ellipse, hyperbola, or parabola.
Thank you, right? And what is that E? The E is always the multiplier of either sine or cosine in here. So in short, in here, your E is equal to what?
Eccentricity.
1/2, right? So if your E is equal to 1/2, what can we say then? Is it an ellipse, a parabola, or a hyperbola? Well, how do we know that? Once again, let's take a look in here. And again, E is basically the ratio between what? Any point distance to the focus and any point distance to the directrix. Okay, whatever that ratio is, that's your eccentricity. So with that being said, if your E is 1/2, what can you say? Is it ellipse, parabola, or hyperbola?
It's ellipse. No, sorry. It's
1/2.
hyperbola.
Ellipse,
Oh.
right? Yeah, because your E is less than 1. Okay. So if your E is less than 1, which is this one, is 1/2, then we know that this is an ellipse. Okay. An ellipse certainly should look like this one here. Okay. And from there, we can also identify step number 3. Okay. K. K is what? K is the multiplier of E. So in short in here, if that is 1 in here, okay, I'm gonna use blue. If this is 1, that means what? That KE is equal to 1. And since your E is 1/2, okay, so that means what in here? 1/2 K is equal to 1. Oops. Then that means we can solve for K. In this case, your K is equal to 2. Okay, so with that being said, that is where the directrix is. Where is that one? At K is equal to 2. So in short, it's going to be somewhere here. X equals 2 for that directrix. So trying to see how it looks like. And let's see, okay? 2 all over 2 plus cosine theta. Let's see how it looks like. 2 all over 2, oops, sorry for that, R first. R equals 2 all over 2 plus cosine, there you go, theta. Okay, so as you may notice in here, where's the focus? The focus is the origin, okay? There's the vertex, and the directrix is gonna be somewhere at where? X is equal to, what did we get again, guys? 2 for that. Okay, help us out with this one in here. R is equal to what? 2 all over 1 minus 3 sine theta. So, first of all, what do we do?
Could you scroll just a little?
Sure, no problem. So once again, just a summary of what we did. Step number 1, make sure that the constant of your denominator is equal to 1. And how do we do that? We'll divide up and down by whatever that constant is, okay? Second, get the eccentricity E. Yeah. Because that's gonna tell us if it's ellipse, hyperbola, or parabola that we're looking for. And third, if we're looking for directrix, whatever that K value is, that is the directrix, okay? So it depends on, certainly if your ellipse is horizontal, therefore the directrix is vertical line. And certainly that is for cosine. For sine, if your ellipse is vertical, then that means your directrix is horizontal instead, okay? So, from this, what do you think, guys, is this one? What kind of conic section is this? R is equal to 2 all over 1 minus 3 sine theta. Okay, so as you may notice in here, your constant term below is already 1 anyway, so we don't need to do anything about that one anymore. We can certainly see what our E value already is, right? So what's our E value in here? Equal to how much? Actually 3, right? That is your E, right? Okay. So that's basically always absolute value anyways, right? So if E is equal to 3, what type of conic section are we looking for? Hyperbola, parabola, or ellipse for such? Anyone, guys? Again, look at our table of values for that, okay? Ellipse if it's less than 1, if it's equal to 1, parabola, and if it's greater than 1, hyperbola. What do you think, guys? Hyperbola, right? As simple as that. So with that being said, and honestly, you can graph it. Just graph it as well, okay? So, we're just analyzing it first before actually graphing it. But certainly if you graph it, you're gonna know already how it looks like. So we know that it is a hyperbola. Since that is sine, we know that it is what? Vertical, okay? Like such. So let's see how it looks like, just to verify with our case in here. 2 all over 1 minus 3 sine theta for such. Here it is. 2 all over 1 minus 3. And this is sine. Okay, 3 sine theta for that. So as you may notice, that is the hyperbola now, right? Where the focus is the origin, okay? And the vertices are below that in there, okay? You good? Any questions, guys? Any questions with what we did? So try to analyze them for such in here. So certainly this is a hyperbola for that. Okay. So again, just trying to revise what we did in here about the opening. Okay, so yeah, just trying to clarify this opening in here. It should not be opening, but instead the vertex where it is. Okay, so here it is for such. Ouch. Okay, if your sign is negative, then the vertex is what? Below the focus, all right? So from the focus, 0, 0. Okay, there we go. Now, if your cosine is positive or negative, then that means left. Okay. This is vertex, right? Vertex. Left for negative. Right for positive from the focus. And the focus in here are always where? At the origin. 0, 0 for that. Okay. So, try to do... So we're done with that. Okay. Is it the last one in here? Okay, so this is the last one in here. Okay. What do you think, guys, is the eccentricity of this conic section? E. Very good, right? 1. Certain, okay. Because there's nothing in there. Automatic, that's equal to 1, right? So E equals 1. Again, your constant term in here is 1 already, so we don't need to do anything anymore. Okay. So if that eccentricity equal to 1, what kind of conic section are we looking for? Are expecting it to be ellipse, parabola, or hyperbola, guys? Parabola. Certain. Very good. Again, ellipse if it's less than 1, but positive. Hyperbola if it's more than 1. Okay. Good for that. Now, determine any vertices of the conic represented by the equation vertex. In this case, we're looking for just one vertex because this is a parabola, okay? But certainly if it's an ellipse or hyperbola, it has 2 vertices for that, okay? So, let's graph it. What's that again? 5 all over 1 minus 1 cosine theta. Five all over 1 minus 1, and this is cosine theta. Here it is. Okay, so trying to analyze this, first of all, where's our focus? Our focus is always at the origin in here, okay? So that is your focus, 0, 0. R is equal to 0. Theta is equal to 0 as well. Okay, with that being said. So that is somewhere here. Where's the directrix? So if we look at here, your KE, yeah, very good, 5, right? Because your E is 1 anyway, so 5 times 1 is equal to 5. So certainly your directrix is at the following, okay? x is equal to negative 5. Okay, so as you may notice in here, that is the directrix for such. K equals 5. So that means, what does it mean? That, say, from focus, okay, so from focus to that point, so any point on the parabola, all right? So from focus to that point is 5. From this point to the directrix is also 5. That means the eccentricity is 5. The ratio between 5 and 5 is equal to 1. Okay? But anyway, in here, where's the vertex? Where's that vertex in here, guys? Well, we know that the vertex in here is midway between the focus and the directrix. So what is that point? Anyone? This is negative 5. That is 0. Where do you think is that one, guys?
Negative 2.5.
Negative 2.5. Okay, so as simple as that one, that is at negative 2.5, 0 for that. Okay, so with that being said, that's what we're going to put in here for such. We can write in here as follows, negative 2.50 degree, radians. Or we can also write the following, right? 2.5 as your r. Okay, this is your theta. And then 2.5 as your r, and then pi as your angle. Okay, so any of those two should work for that. Okay. Now, there's also another one that is what we call how to convert from polar to xy, rectangular equation. So how do we do this? Okay, step 1 is as such. All right, Elena, let's read step number 1. Please, thank you.
Remove denominator by
Multiplication. Okay. What we call MPE, multiplication property for a quantity. So in here, if you want to remove that denominator, what do? Well, we're going to multiply both sides by that, okay? 1 minus cosine theta, and this one is also 1 minus cosine theta. Okay, so if we do that, then this will cancel out. Hence, this can now be seen as follows, okay? R, 1 minus cosine theta, is equal to, this 2 will cancel out, equal to 5. Okay, and with that being said, we can now distribute this in here. R minus R cosine theta is equal to 5. Good, guys, with what we did so far? Now, after this is what we're gonna do. Step number 2. Step number 2, James, okay, you read from there. Isolate
We're going to isolate the constant
term,
term r, and square
both sides
both sides.
of the equation. All right.
Of
Yeah,
the
sorry.
equation.
Yeah, sorry for my abbreviation for that. So this r in here, constant term, not this r, but this r constant term should be isolated. So in short, how I'm gonna remove this one and put it on the other side. Okay. So how do we do that? Basically, just add both sides by r cosine theta. Okay. Oops. And with that, this will cancel out. Hence, I have this now in here. R is equal to what? 5 plus r cosine theta. Okay. Now, also, I'm gonna put in here something like this. Okay. So, um, replace r cosine theta, if you see any r cosine theta with x, and any r sine theta with what? With y. Okay, so recall our polar coordinates for that. So that means this r cosine theta, I'm gonna replace that one with x. Okay, and this is now 5. Okay, so r is equal now 5 plus x. Now I'm gonna square both sides now and see what's gonna happen. Square this two. Okay, so we have now the following. R squared is equal to what? If I square this, that'll be what? Square the 5, that's 25. 2 times the first and last, so that's 10x. Plus square the first term. Okay. Step 3. Okay. Almost the last step in here is what? Replace any r squared with what? What do we know with r squared, guys, in terms of x squared and y squared? That's the Pythagorean theorem for that, right? So assuming if you have seen that, then you can replace that one already with x squared plus y squared is equal to 25 plus 10x plus x squared. Okay, and then from there you can now express conic section in conic equation in standard form, if you want it to be in standard form. So honestly in here, the x squared will cancel out. Oops. Okay. And basically that's it, right? We're done with that one already. That means that y squared is equal to 25 plus 10x. That's basically our conic section for that. Okay, what's that again? Y squared is equal to 25 plus 10x. And we can verify that one in here as well. Y squared is equal to 25 plus 10x. Okay, and as you may notice in here, this graph of the rectangular and that graph of the polar are basically the same. Okay, yeah. So again, that is not a part. It's basically just additional skill for you guys, but there's none in our WebAssign homework that actually asks you to translate the polar form to rectangular form. But again, that is just like an optional and additional skill or detail for such, just for you to see how related the polar and rectangular forms are. Okay, so if you have questions, let me know about that one, guys.